A pot of warm soup with an internal temperature of 105 degrees Fahrenheit was taken off the stove to cool in a 68 degree Fahrenheit room. After 26 minutes, the internal temperature of the soup is 95 degrees Fahrenheit. Using Newton's law of cooling, the temperature is given by T of T equals 37 times E to the power of negative 0.012119 T plus 68, where T is the time in minutes. For part A, to the nearest whole number, or nearest minute, how long will it take for the soup to cool to 84 degrees? To answer this question, we substitute 84 for T of T and solve for T. This gives us the equation 84 equals 37 times e to the power of negative 0.012119 T plus 68. To begin to solve for T, we first need to isolate the base e, which indicates we first subtract 68 on both sides. Simplifying, we now have 84 minus 68, which is 16, equals 37 times e to the power of negative 0.012119 T. Next, we divide both sides by 37. Simplifying, we have 16 37ths equals e to the power of negative 0.012119 T. Next step is to take the natural log of both sides of the equation. Now we apply the power property of logs on the right side of the equation, which indicates natural log of e to the power of negative 0.012119 T equals negative 0.012119 T times natural log e. And natural log e equals 1, and therefore to solve for t we divide both sides by negative 0.012119. Simplifying, we have t equals natural log of 16 37ths all divided by negative 0.012119. And now we go to the calculator and round to the nearest whole number or nearest minute. I also want to show how we could have solved this graphically using the intersection method. To do this, we'd enter T of T in the graphing calculator and then enter T of T equals 84 and look for the point of intersection. Going to Desmos, first notice in cell 3 we have the quotient which equals T, which to the nearest minute is 69 minutes, and then above I've also entered T of T equals 37 times e to the power of negative 0.012119 T plus 68, as well as the constant function T of T equals 84, and the graph is on the right. Notice the T value of the point of intersection gives us the same value for T. The time it takes for the soup to reach 84 degrees Fahrenheit. So again, we now know that T is approximately 69. So for part A, how long will it take for the soup to cool to 84 degrees? The answer is approximately 69 minutes. Part B, to the nearest whole number, what will the temperature be after 2.5 hours? We need to be careful here because for our function T of T, T is time in minutes, not hours. We know there are 60 minutes in an hour, and therefore 2 hours is 120 minutes. And because the time here is 2.5 hours, we want to use T equals 120 plus 30, or 150. Which means we need to determine the approximate function value for T of 150, which is equal to 37 times e to the power of negative 0.012119 times 150 plus 68. And now we go back to the calculator. In cell 4, we enter 37 for e, press ABC, and then press E. Back to the number pad, click on the exponent key. Because we have a product in the exponent, we need to enter the exponent in parentheses. So we have open parenthesis, negative 0.012119 times 150, close parenthesis, right arrow, plus 68. To the nearest whole number, t of 150 equals 74, which indicates after 2.5 hours, the temperature is 74 degrees Fahrenheit. I hope you found this helpful.